This is quantum energy and photons homework 1, problems 4 and 8 explained. So let's get started with problem 4. The problem says that radiation is emitted from human skin and it gives you the wavelength. And for parts A, they want you to find the frequency. Part B, they want you to identify the type of E&M wave it is. And part C, they want you to find the energy in electron volts that's carried by 1 quantum of this radiation. So you're given the wavelength initially, and since it's not in a standard SI unit, you have to convert it, and this is the converted wavelength. And after that, since you know it's an E&M wave, you have to assume it's traveling in a vacuum. And this is the speed that travels in a vacuum, so you can use that to find frequency. And after you find the frequency, which is part A, you can use that for part C. But then part B is asking for the type of wave it is, E&M wave it is, and based off your prior knowledge, you know that there's radiation, micro, infrared, visible light, ultraviolet, X-ray, and gamma rays. And the wavelengths according in that order are 10 to the third, 10 to the negative second, 10 to the negative fifth, 10 to the negative 6, 10 to the negative 8, 10 to the negative 10, 10 to the negative 12. And based off of your wavelength given, you can assume it's infrared because that's the closest one, which 10 to the negative 4 and 10 to the negative 5. And that's how you identify it. So C, for part C, they're asking for they're asking for energy in electron volts. So you're given this formula right here to use, and you can use E is equals to HF. And you have your frequency from part 1 that you can plug in, and you have Planck's constant, and you know that. And the way for you to know which one to use is you see what you're looking for and what cancels out. So this one is 1 over, you can convert hertz, which is frequency, as 1 over T. And that seconds on the bottom, so it cancels out to leave joules. So this is what you're left with. And after that, they're asking for an EV, so you have to convert joules to electron volts. And you're given the ratio 1 electron volt is equals to this many joules. And after that, you're left with this final answer. So yeah, part A was finding frequency, part B was identifying it, and part C was finding the energy in electron volts. Okay, now to problem 8. Problem 8. So it says, suppose that we know that an electron emits a photon having a wavelength of 1.43 times 10 to the negative 7 meters when it transitions from an unknown energy level to the second excited state, n equals 3, as shown below. On which energy level did it initially start? Okay, so we're given a graph, and that will be used for the next part. So the first part, they're asking for, oh no, it's not in parts. We have to find the frequency in order to find the energy, and after we find the energy, we can use it in the formula E is equals to change in E, and find EI, which is the initial. That's what they're asking for. So once again, it says photon, which is a particle of light. So we can use this formula right here to find the frequency, and after that we can use this E equals HF to find E, like the total energy. And after that, once we find E, which is this number right here, we converted it obviously using the ratio given to us. And after that, we put the total energy into this formula, E equals change in E, and we looked at the chart given to us to see that N at the second excited state, it has 13.6 electron volts. So we put that into this formula right here, and we're left with one variable left, which we're trying to solve, EI, and using algebra we move it over and we get that EI is equals to negative 4.9 eV. And after looking at the chart, we see that that is at n equals 5 or level 5, and that's how you get your answer.